done by today's guest star, Chaffee Duckers, who is leaving us after today. So,
Okay, so we got a dump truck. Dump truck's being filled with sand. Sand falling straight from the rest from the height of 2 meters above the truck bed, and the mass of the sand hits the truck per second is 55 kilograms per second. The truck is parked on a platform of a weight scale. By how much does the scale reading exceed the weight of the truck and the sand? Okay, and the way I think of it is that the weight exceeds what it actually is because the force of the sand falling is pushing down on it. So that's basically what we are solving for. Yeah. Okay, so we have our delta, I guess, y, is 2 meters, and then our final velocity of the sand is 0. And then we have this value of 55 kilograms per second, which will come in handy later. And then, so here's what you do. So, okay, I can do it. Come on. Okay.
It's your report.
Irrelevant.
here, put the pen down for a second. Now pick it back up.
So, I'm trying to remember how I did this. So, there's this equation sometimes, and it's impulse, right?
Mm-hmm.
Okay, equals delta p. So that's change of momentum. So this is ft equals mv final minus mv initial. Yeah? Yeah, okay. And with the MB final, one of them is 0. I can't remember.
You tell me.
Peace out, Girl Scout. So we we have ft equals negative mv initial. So the force is equal to negative mv initial over time. That's a long looking line. And so we have, conveniently, look at this value, mass and time.
Mass over time, excellent
Would have thunk.
dimensional analysis, right?
Would have thunk. See, there you go. So what do we need now? We need this value. Consequently,
This value being final velocity.
yes. So
Initial.
All right. Initial meaning as it strikes the truck.
Yeah. So remember kinematics? Yeah, me too. So we're gonna do some of that and see you later. No, just kidding. Rewind.
Actually, you were right the first time because what we're doing is a different interval. We're doing the time that the sand is falling, not the time over which the sand is coming to rest, okay? So the V final at the end of its fall is the V initial that you want. Does that make sense, everybody?
Yes.
All right, we have a period of time that the sand is falling. That's how we know how fast it's going to be going, which we're calling the initial velocity, right, for the part of the problem that Chaffee's doing. The initial velocity has to slow down to 0. Okay, so in other words, it speeds up from rest to some velocity at when it strikes the truck, okay, but then it slows back down to 0, okay?
So what are we doing first? Chunky, you just said in the second one.
Right now she's finding out what the velocity is as it hits the truck. That's what we're going to plug into the F equals mv initial over t.
So in other words, just okay.
Yeah, the final velocity for her part of the problem is the initial velocity for the actual problem. Okay? So v squared
Equals 2a delta x, so 2. And since the sand is falling downward, what's the acceleration?
Gravity.
Whee! Yes. Meters per second. Squirt. And then your delta x is your 2 meters, and so that's some stuff. Yeah, final solve for because math.
Calculator people, help out.
Let's go! It's 6.26. Yay! Meters per second. And then alley-oop. And then we've got some 55 kilograms times 6.26 meters per second over 1 second. Consequently, 300